Hey guys, welcome back to TechNSArena, your go-to channel for all things tech. In today's video, we are gonna solve the range and IQR or interquartile range problem. We'll do it in our Jupyter notebook and use Python to solve this problem. In our previous videos, we solved the standard deviation of the sales data problem and then also visualized it. If you haven't watched it, make sure to check them out as well. Alright, let's jump right into our problem statement. We have been provided the following dataset representing the exam scores. Our tasks are to calculate the range of the dataset and the interquartile range or IQR of the dataset. We'll solve this problem using three different methods. First, we'll use NumPy to calculate both range and IQR. In the second approach, we'll use Pandas. And finally, in the third approach, we'll find the range using Python's built-in max and min methods. And to calculate the IQR, we'll take a small help of the statistics library to make it easier. But before we directly jump into the solution, let's discuss some important concepts. So first, what is the range? The range of a dataset is the difference between the maximum and minimum values. It gives us an idea of the spread of the data. The range can be very sensitive to outliers because it only considers the extreme values. And second is interquartile range or IQR. The IQR measures the spread of the middle 50% of the data, giving you a better idea of the dataset's variability without being affected by outliers. It's calculated as the difference between the 75th percentile and the 25th percentile. The IQR is less sensitive to outliers because it focuses on the central position of the data. In short, the range looks at the extreme ends of the data, while the IQR looks at the central part of the data and ignores outliers. Understanding these concepts is crucial as they help us get insights into the variability and distribution of the data. Okay, let's solve our problem now. Here we already have a dataset in the form of a list. So let's just copy it. Okay, as I said earlier, first we'll solve it using NumPy. Okay, so let's import it now. As we know, the range is the difference between the maximum and minimum value. So here we can use NumPy's max and min functions. And here we got our range value, which is 90. Let's proceed and calculate the interquartile range or IQR. For this, we have a percentile method in NumPy, which we can use to find Q1 and Q3, which are 25th and 75th percentile, respectively. We already know that IQR is the difference between Q1 and Q3. And we got our IQR value, which is 41.25. Method 2. Pandas. Pandas is a popular library for data manipulation and analysis. You can use Pandas series to calculate the range and IQR of the dataset as well. So first let's import Pandas and create a dataset as a Pandas series. In Pandas series, we have a quantile method that we can use to find Q1 and Q3. Now we can simply find the difference, which will give us the IQR value. Here, I didn't do it for the range, as we can find it with the same process we did in NumPy, using the max and min methods. We can do the same with Pandas data frame as well, with the same logic, which will give us the exact value for both range and IQR. You can try that later. Method 3. Let's calculate the range manually, and for IQR we'll take a small help of statistics as well. In Python, when we want to find the maximum and minimum value of a dataset, we can simply use the built-in max and min functions. Now we can simply find the difference between them. Our range value is 90, which we got earlier as well. To calculate the IQR, let's first sort the dataset using the sorted method and store its length, let's say in n. Now we have to split the dataset into two halves so that we can find the quartiles Q1 and Q3. Now we'll import our statistics library to make it easier to find the medians. Now that we have gathered everything together, let's simply find the quartiles. Alright, now we can simply find the difference. Here we got our IQR value. The difference in the IQR values is due to the different ways of calculating the quartiles. NumPy uses linear interpolation, which can give different results than the manual calculation method of finding medians of the halves. Both methods are valid but are based on different interpretations of quartile calculation. To ensure consistency, you can choose any of the methods and stick with it for your analysis. To summarize, we have calculated the range and IQR of the dataset using three different methods in Python, which are NumPy, Pandas, and a manual approach, where we took help of the statistics library for calculating IQR. While calculating for IQR, we saw that NumPy and Pandas gave the same IQR value, but the manual method gave a different value. That's because NumPy calculates the quartile differently than the manual method. As I said, NumPy's percentile function uses linear interpolation, which can lead to different values for Q1 and Q3, especially for small datasets. In contrast, the manual method calculates the medians of the lower and upper halves of the sorted data, which can yield slightly different results. By comparing both range and IQR, we get a fuller picture of how our data is spread out. The range tells us about the overall spread, while the IQR gives us insight into where most of our data lies. And that's all for today. We'll solve more real-world data science and analytics problems in the future videos.